So here we are in the tutorial creating Shiny apps with Rhino, the new framework for Shiny apps. Our speaker today is Kamil Silla. Kamil is a full-stack engineer at Epsilon and a core developer of Rhino. He has a background in computer science and mathematics. His professional interests include programming language theory, software development processes, and working across technologies. With us, we also have Ian Moore, who works on the Epsilon team as the technical evangelist, which means that his role is a blend of the sales and marketing team. He has a background in mathematics, has been using Shiny for 7 years, and is one of the people responsible for the Shiny weekly newsletter. So without any further ado, Ian, the floor is yours.
Hi, everyone. Thank you so much for joining us today. And Macarena and everybody at the Latin R Conference Committee, thank you for having us here today. What we're going to be doing in this workshop today is we're going to be talking about Rhino, which is a relatively new package. We just announced it in April at the Shiny conference. Basically, what Rhino is at its core is it's a package to help the average user create enterprise-grade applications the Epsilon way. So what that means in general is that it helps you in 3 main areas. The one is in clear code, which allows you to build scalable app architecture, modular code based on the box package and Shiny modules. It also will help you with your app quality, helping you with unit tests, end-to-end tests with Cypress, logging and monitoring and linting. And then the third thing is helping you with automation. So that's going to help you in your project startup, CI actions with GitHub Actions, dependency management with Rend, configuration based on config package, SAS and JavaScript bundling with ES6 support via Node.js. I'll be passing it off to Kamil in 1 second. The reason I'm here is to help Kamil with the chat. So I will be chiming in occasionally to stop Kamil if we have a good question that happens to line up with the moment. Otherwise, I'll be keeping track of everybody's questions so we can have kind of a Q&A session at the end. So with that being said, I'll go ahead and pass it off to Kamil, and please feel free to add your questions to the chat.
All right, thank you. So let's get started. So as Ian mentioned, this will be an introduction to Rhino. I mean, this tutorial is a kind of complete overview of the various features that we have here. And Ian gave a pretty good description of what Rhino is. But in the end, it's just an R package, an open source one. So first thing first, if it's an R package, you can get it in a standard way. And you might already have Rhino, but I'm still going to just like show you what it looks like. You can use the typical function for installing packages, and with just passing Rhino to it, we can grab it for run. So while this is getting installed, let me give you an overview of how this tutorial will look like. So first of all, I'm assuming that you're familiar with R and Shiny. Rhino is a framework for building Shiny applications. There will be certainly too much to cover if I was to also start describing what Shiny is. So I'm assuming that you're not necessarily an expert, but certainly are familiar with it, and you made a couple of applications, hopefully, so that you'll be able to understand what's happening, at least in terms of Shiny. Because Rhino as a framework for creating Shiny applications adds a lot of things on top. This whole presentation, I will be leaf coding an application in Rhino from scratch. And I do have this scripted, so in some situations I might copy and paste a little bit of code to speed things up or to avoid some mistakes. And I don't really expect you to follow this tutorial. Rather, you can see it as an interactive presentation where you can like see a tour of all the features that are available in Rhino. And I encourage you to ask questions as we go. Ian will interrupt me when he sees a question related to something that I'm currently doing. I think it works really well if I answer this kind of questions right away. And last thing to add, this tutorial will be based on a Rhino tutorial that we have on our documentation page. And I just want to quickly show you that resource. If you search for epsilon Rhino, one of the first links that you'll get is our documentation page. And I will maybe show you later one more article, but I won't keep referring to it all the time. But most of the things that I will be describing can be found here. And this tutorial in particular is based on the tutorial that we have here. So I think we can now get started. What I have here is VS Code open. Feel free to use RStudio for coding or whatever else you prefer. This is my editor of choice because I work with other languages than R as well quite often. It's also quite convenient for presentation here. But RStudio does come with some nice small additions, especially for Rhino. In particular, it allows you to create a new project using graphical interface. There's like new project wizard, but here we will use the terminal. And the way to initialize a new Rhino application is to call this Rhino init function. I'm not passing any arguments here, so it will create a Rhino application in the directory that I'm currently in. You can see some output, which tells us what happened and what packages were added. And all the files here on the left, this is a fresh project structure of a new Rhino application. It can look a little bit daunting at first, but don't worry about it. We will cover most of the things one by one. I actually won't be able to show you all the features of Rhino, only the most important ones. But it's really not as complex as it might appear at the first look. So actually, let's take a quick glance at what we have here. And perhaps one file that stands out is this app.r. In a simple case, you could have an application, a Shiny application, which uses nothing but this app.r file. You can define your UI and server here. In case of Rhino, you start with just this small snippet of code in app.r, a call to Rhino app function, and a note not to edit this. This is because the actual entry point to a Rhino application is in the app main R file. And I will tell you in a moment why it's set up this way. But for now, we can actually run this application right away. So if we start up our terminal, we can just use Shiny run app. And this will open for us this application, which doesn't really do much now. It just displays a hello message. And if we take a look at this code here, you can see that this is actually what it should be doing. So to quickly overview what's happening here, because this probably looks a bit different to you from a typical Shiny application. So at the top, we have box imports. Instead of library calls, whenever you are working with Rhino, you will be using box use to explicitly say which packages and functions you are using in your application. So you can see that actually in each file. So you can see that here I have Shiny and the particular functions which I'm using inside this file listed. Then there are two functions defined in this file. Both are functions of ID. This pair of functions form a Shiny module. A standard thing, you can read about it in Shiny documentation. I won't be going into details here. What this does for us is basically adds scoping to the IDs that we provide for inputs and outputs. And the idea behind Rhino is to build your whole application in a modular fashion. So most of the UI will be built using this kind of files, which will be exporting UI and server. We will see that in a moment because I will be adding a couple of modules to show you that. And this simple module is the top level UI of our application in this main R file. It just displays a hello message and it renders it on the server just so that you can see that everything works correctly and nothing more at this stage. All right, so let's actually get to doing some things. And first of all, let's add all the files that Rhino created to us to Git. So along the way, I will be kind of showing you what the actual development process looks like with Rhino, including some debugging sometimes, running linters and so on. And this includes actually using Git. So at each step, I will be committing the changes that I'm introducing to the application. It will be also a good moment to review what actually happened in any step. Right now, we just have a bunch of new files, everything added by Rhino. It's important to commit everything. For example, don't forget about .rprofile. It contains important setup that is necessary for Rhino to work correctly. So I can just add everything. And we're good to actually start doing something. Maybe one last thing, I will restart my R session because this will reload this R profile. And as I said, it contains some important setup. While everything should work without it, we can certainly make sure to avoid any errors. So just a quick restart. All right, first of all, I will be adding a couple of dependencies. So my goal today is to build a simple toy application to showcase you all the features. And I will give more details on that in just a moment. Let's start with adding a couple of packages that I will be using. So to do that, I will open this dependencies R file. And this, again, might be slightly surprising because we have our env here, as you might have noticed, a package which we use for adding dependencies. Typically, we use just directly that, just renv install, renv snapshot. But we do have this dependencies R file. And a quick note here, as I mentioned, we have extensive documentation for Rhino. And if you are wondering how to do anything, it's always a good idea to take a look at what we have here at the top. We have the documentation divided into a couple of sections. The tutorial is the thing that I mentioned at the beginning and also the basis for what I'm presenting right now. There is this explanation section with kind of articles that go in depth on some topics and let you understand the background of why some things are the way they are in Rhino. There are how-to guides which give nice recipes for most common tasks. And also there is the reference, which is just the standard thing that you would see for any R package with descriptions of all the functions. Right now, I want to show you one of the how-to guides, in particular, how to manage R dependencies. This is what I'm trying to do right now. I open this up and I see a couple of recipes for the most common things. So to add a dependency, it tells me to first add a library line to this dependencies R, then call renv install and renv snapshot. So this is what I'm going to do. I won't be going back to this documentation more to point you to the various places where you can find information, but please just do remember that it exists and it will be expanded as we are working on Rhino, because we see documentation as like a very important part of this framework in general. So in this file, I need to explicitly state what packages I will be using. And I'm going to, first of all, add React table. I will use it to display a nice table with some data grabbed from the Rhino package. And I will use also eCharts for R to display the same information in a chart, in a line chart. Now for some data processing, I will need dplyr and tidyr. And lastly, I'll need HTML widgets. Just for a single helper function, you'll see it as we move on. So all of this should be just like library calls, just like this example one. And this is the only place in Rhino when you will see these library calls. This is actually just a place where you list the dependencies. Having them here doesn't mean that you can use all the functions from these packages in your code. You do need to declare explicitly what you need in each file, just as I was reviewing that on the example of main R file. And just before we save it, I'm going to sort this alphabetically. This is something that I always recommend to do whenever you have a list of items where the order doesn't really matter. This way, you don't have to wonder where to add your edits. And it has the advantage above, for example, adding everything below, that you will face less merge conflicts if you work with another developer. So the list always have a specific order, and the alphabetical ordering also makes it easy to find anything on this list. After adding the dependencies here, I will need to go to rn and actually install these packages. And I actually can run install without any arguments. It will automatically see all the missing packages and add them. And lastly, we take a snapshot to update the log file, which contains the exact package versions and sources that, that we have added. All of the steps are mentioned in the recipe in the documentation that I showed you a moment ago. So this is it for adding dependencies. Let's commit and summarize what happened. So we edited the dependencies file to explicitly list the packages that we need, and then use some rn functions to update rn log. All right, so we can actually start doing some coding now using the packages that we introduced. And the first thing that I'm going to do is to add a table which will display some data set which comes with Rhino. So Rhino comes with a simple data frame with 3 columns: year, population, and species. And basically, this data set tells us what was the size of a population of the 5 different Rhino species throughout the years, starting in like 1800, I think. And I'm going to display this data in a tabular form. So first of all, I'm going to define the logic of kind of transforming this data into the table form. So if we take a look here at this app file, in this app directory, we have 2 directories here called logic and view. And whatever I will be coding, I will try to separate into 2 parts. One part will go into the logic directory. This is where I will try to keep code which can be expressed without referring to Shiny. So without using UI builder functions, without using reactivity. This will help me to then make this code testable and maybe reuse it in some other place. And separately, I will define Shiny modules, which will go into this view directory, which will be actually responsible for displaying pieces of UI, wiring everything together using reactivity, inputs, and outputs. So I'm going to start with the logic part here and just create a new file called rhinos.r to implement the logic for this part.
Hey, Kamal, really quickly, we got a question come through that was asking about VS Code allow you to enable R. I believe that means, are you going to the terminal and how are you starting your R session? If you could clarify that just a little bit.
Yeah, absolutely. So basically, well, I'm using a shortcut. I forgot where this is in the interface, but I start my session using just the terminal functionality of VS Code. So by default, it starts my shell for me. I'm working on Linux here, and like I have ZSH here. Typically, you would probably get Bash. Same thing if you worked on Mac. On Windows, you'll, I guess, get command line here. And what I do, I just launch R from here. So I type capital R, and this triggers our terminal for me. I believe there are other ways to do this because there is some plugin for VS Code which adds improvements regarding working with R. But to be honest, I don't really use too much of this kind of functionality. I kind of like to work bare bones, just with the terminal and text editing. So this is how I do it. I hope that answers this question.
Yeah. Thank you, Irma.
All right, back to our logic for displaying a table of rhinos. So I created a rhinos.r file, and this is where I will define a couple of functions. First of all, I will create one called fetch data. And this will be kind of a mock example. So inside of here, I will just return this data set that we were just taking a look at. Normally, this function would probably take some arguments and do things like connect to a database to fetch some data. And I want to kind of simulate that here so that we can see a bit more real-world-like structure for our application. But otherwise, I won't be doing anything more with this function. And to be able to actually use it from other modules, I need to add an export statement here using a Roxygen comment, just like you would do for exporting package functions. So this is, again, functionality of Box, which we use for this explicit imports at the top. I will cover a bit more features as we go, but if you want a really in-depth understanding of how Box works, it's best to go to the documentation of Box directly. Moving on, actually, as I'm using this data set here, as I said, we should explicitly mention everything that we are using. And right now, I will just mention Rhino here. A quick note here, typically, you will see me using a $sign to refer to any functions or objects from the package that I imported with Box use. However, as of now, there is a slight limitation or a bug, you could say, in Box, in that it doesn't really work for datasets. So I have to use double colon here, otherwise it won't work. But this is the only place where we will need to do this. All right, so I have a function for fetching data, and now I'm going to define a function for making it into a tabular form, which can be displayed in our application. So I'll just call it table. It will be also exported. And let's start really simple. What I will do is just take the data and pass it on to React table. Of course, we need to import it. And this time I will use this syntax to get just this single function from the package. And actually, before even plugging this into our application, we can test this right away. I'm going to go to the terminal. And with Box use, I will import app logic Rhinos module. And we can see that inside of this module, we have two functions defined, the ones that I just wrote. We have the fetch data function. I will just call it to save data into a variable. And then we have this table function, which I will just launch. And what happens, we see a preview of the HTML content of this table. So in a moment, I'm going to put this into my application, but first I'd like to add a couple of improvements here, because currently this is just a display of the data frame as we saw it when we were taking a look at the data. And first of all, I don't like how this species column works. Instead of having species and the name of the species, I would like to have separate column for each species and the population of that species listed in that column. And the second thing I don't really like is the order of the years. Like, it looks like it's almost in order, but then it starts going down again. So I will order everything by year to make it look nicer. Going back to our code. For this first task, I'm going to use tidyr, and in particular, the pivot wider function from it. So with the names from argument, I will tell it which column to transform, which values from the species column will be transformed into column names. And then for each of these new columns, I will specify where to take the value from to populate it. And I will use population here. And before we try this again, I will also use dplyr to arrange everything by year. And we will also need to include dplyr here. So going back to our terminal, we can now use box reload function to reload this module that we are working on. You can think of this as sourcing this module again. I need to do this, otherwise we will just see the old code. And we still have the table function here. We can launch it, and we can see that we achieved what we wanted. We have now 5 columns, 1 for each of the different Rhino species. Everything is sorted by year. I like it. I'm now going to put this into my application. So we have the logic for displaying the table ready. Now let's move on to defining the actual Shiny module that will be responsible for displaying it. For this, I'm going to create a new file in this view directory and let's call it table R.
Really quickly, Kamal, we got a question from Natalia asking, why do we need to rename the table function and why can't we just use React table directly?
So it's not that we are really renaming this or that we need to do this. The idea behind the structure that you are presented with here is to make the code more maintainable, more organized, more understandable. And by the way, if you'd like to organize the code of your project in a different way, you are free to do that. Rhino comes with this logic and view directories, which you are free to remove, rename, or use other directories, or just use one directory for all your sources. But Rhino comes not only with a structure and the tooling setup, but also with some philosophy and ideas behind the whole thing on how to approach building Rhino applications. And I will actually refer to our documentation once more here, because we have an article exactly on this topic. There is, in the explanation, there is this application structure article, and it talks a little bit about the philosophy behind this and the separation into logic and view. Feel free to read it later. I'll just give you a quick description now. So the idea here is that we want to keep everything that can be expressed without Shiny separate, and we want to express without Shiny as much as possible. This is because code which does not use reactivity or like Shiny interface function is much easier to test using unit test. It's also much easier to reuse in other places. And we try to only limit Shiny to actual definition of the UI, of the layout, of the IDs, and the way that things are connected together. So I hope it will get a bit clearer as we move on, and also at the end when I will add some tests for the functions that I'm defining here. But in general, we have this separation because this is something that we saw working for us in our project. The rationale is keeping the code organized, testable, maintainable, but feel free to structure it in the way that works for you best. So I hope this answers the question. I will now move on and continue adding a table to our application. So we have, as I said, the logic for generating the table defined. Now I'm going to create a Shiny module responsible for actually displaying it. And first of all, let's add a bit of code that we will typically need in any module, just like you saw in the main R file. So I'm going to import Shiny and define 2 exported functions here. First of all, we will need the UI of our module. And then we will also need the server function. Both are functions of ID because we keep everything being Shiny modules. And we need some basic structure here. So for our UI, we'll need the namespace function. And for our server, we actually need to wrap the actual server in this Shiny module server function. So I'm not going to go into details here. This is a mechanism that is available in base Shiny as well. So you can refer to Shiny documentation to read more about Shiny modules here. All right, and this is going to be a very simple module. It will just grab the data and display it using the function that we defined in our logic part. So first of all, I'm going to import this logic module, which we defined a moment ago. And I'm also going to import a couple of functions from React table. In particular, I need React table output and also the render function. So for my UI, it will consist just of the output and nothing more really. And for my server, I will be just rendering into the table. All right, and inside of this render React table, I'm going to call this table function from our Rhino module and pass data inside. Where is this data coming from? We will actually define it here. So I will make it a reactive and just initialize it with the result of our fetch data function. So this might look a little bit artificial now because this is just static data. Why not just use it directly? But once again, imagine that what happens here is that we are actually connecting to some database. We might want to modify this data as application is running. For example, if user is trying to read some other table. So we will put this into a reactive to kind of simulate what we'll typically face in a bigger Shiny application that connects to a database. But other than that, we'll just pass the data into this table function. And now you can see this separation in action. This part of the code is just responsible for kind of defining the UI, while the majority of the work happens in this Rhino's table function. And this table function does not rely on Shiny in any way. It just takes plain data frame here, uses some process it in some way, and then uses React table to render it. But as you saw earlier, we were able to run it actually without Shiny, which is sometimes pretty convenient for testing this kind of small components without actually having to run the whole application. So last thing, we have defined our table module here. We need to plug this into our application to actually see it. So I'm going to the main R file here, which is the top level module. And inside, I'm going to, first of all, import the module that we have just defined and replace this example code with the UI and server of the table module. We can also remove a couple of the imports from here. They are no longer used. And hopefully this should now work. So we can try to run the application. And what we can see is basically the same thing as before, but now we are actually rendering this table in a live running Shiny application. And this is what we wanted. So we can now close this step. To quickly review what happened, we did two things. First of all, we defined logic Rhinos module, where I will be defining the majority of the application logic. We also created a view table module, which is responsible for actually displaying the table. And it uses the code defined in the logic module. And finally, we plugged in this new table module into our app main R, which is the top level definition of our UI. All right. So next, what I'd like to do now is to add to this application basically a chart, a line chart displaying the same kind of information. I imagine that for each species, we will have a line showing us how the population size was changing over the years. So once again, I'm going to start with our logic here. And I'm going to define another exported function, which will also take data. And this time I will call this chart. The idea is the same as with the table. I want to take the data and process it in some way so that it can be nicely displayed as a chart. So first of all, I will want to group by species so that we have a separate line for each Rhino species. And then using eCharts, which I will now also need to import, I'm going to create a chart with year on the horizontal axis. And I want a line plotting as the population for each species. This is good. We should be able to, just like before, launch it without actually starting the whole Shiny application. So I'm going to reload the module again. Should, of course, fix any mistakes that we might have introduced, like missing commas. And now, inside the Rhinos module, we should have the chart function. I can run it and pass data into it inside. Once again, let's fix any typos. And we can see the chart rendered successfully. It doesn't look too good though. I will need to fix what we have on the horizontal axis because all the data is squashed here. I will also add some labels so that for each data point, we can see exactly what value is at that point. So going back to our code. First of all, we set the horizontal axis range to be determined based on the year. And secondly, we add tooltips. Reload the module and try to render the chart again. Now it looks good. I like this. I'm going to add this to our application. So we do it in a similar way as before. I will add another file into the view directory called just chart.r, and this will be the Shiny module responsible for displaying the chart. This time, I'm just going to copy the structure over from the table to speed things up a little and remove the code which we won't need in this time. But otherwise, it will be quite similar. First of all, from eCharts, I will need to import the output function and the render function. And once again, our UI will just consist of this single output. And in the server, we will simply render into that output. So again, here I will use the chart function from our Rhinos module and pass data inside. So what about the data now? In the table module, we are fetching it, but I don't want to repeat it in this other module because once again, this is an expensive operation. I'd like this to happen only once per user or when the data needs to be reloaded. So I don't want to call this fetch data function again. So I'm going to do a small refactor here. This table module, instead of fetching the data inside, will just take it as an argument. And then in the main module, I will actually fetch the data. And I will pass it as an argument to our server, to our table server. I'm going to fix a couple of things here. So we need to add the reactive import now. And we also started using this AppLogic Rhinos module here. So we also need to add it to the imports. All right. And I'm going to do a similar thing for our chart function. So this module will also take data as an argument. And last thing to do is to plug this into the main module. So I'm going to add another import here. Keep things ordered. And the last thing to do is to add the UI and the server function. All right, it's quite a couple of changes. I hope I did not make too many mistakes. Let's try to run the application. So first of all, main R file, I'm missing comma. And it works. We now have a simple application which displays information about population of rhinos over time using tabular form and a line chart. So to finish off this step, let's review what changes we introduced. First of all, just like before, we defined the logic for generating a chart in our logic Rhinos module. Then we added a chart module responsible for actually displaying the chart and plugged it into our main R. We also edited the table module to refactor the place where we fetch the data. Now it happens in main R, and the data is just passed as arguments into the modules. All right. So now I'd like to add a couple of small improvements to the simple application. And the first one is just a simple refactor. Nothing that we really need here, but it's a nice thing to showcase one of the cool features of the box package. So you can see that in the main R, I'm now importing both chart and table from this app view directory. And in the future, I will add more modules here, and I would need to keep repeating this app view. But there's actually a nice way to avoid this. And I will use this init R file in the view directory, which Rhino creates for you by default. And this is a nice box feature, which I think is best explained by just showing you how it works. So inside of here, I will import chart and table modules, and I will mark this whole use statement as exported. So what this simply does is kind of take this chart and table and make it available as if it was defined inside of this init R file. And now the init R file works in the following way. It makes the things exported from it appear as if they were exported from this directory above. So instead of repeating this app view every time. What I can do now is I can just import it directly from app view, just like this. And whatever we add there in the future, we will be also able to import using this shorter form. So this was just refactoring. So hopefully the application should start and work just as it did before. It does, so we are good. All right. Now let's take a look at our application. One thing that I notice and don't really like is the year labels that I see on the chart here. They have 1,000 separators, which doesn't make much sense for years. So I'm going to get rid of that. And to do it, I will go to my logic Rhinos module. And what I will need to do is to pass a formatter argument into this function. And the formatter argument will be a JavaScript function. And this is a perfect moment to showcase how you can add custom JavaScript into Rhino application. So in Rhino, you will be typically adding the majority your codes into this app.js directory. This is where all your code will be going. And it is possible to use inside of this directory a custom structure using files and directories, just like you are able to do with the R sources using box modules. With this index.js file, you can use import statement to import code from other JS files. So if your JavaScript code grows, it is quite easy to use this to organize it and keep it clear and understandable. Right now, I won't be creating any additional files because I want to create just a very simple function here. Let's call it format year. It will take the value of the year, and its task is to just output a string, a properly formatted string. And I actually don't want to do anything with this value, but just convert it to a plain string without any comma separators. And I can do it using so-called string interpolation in JavaScript. Now, to be able to use this function in our R code, I will need to mark it as exported using this export keyword. And then I can refer to it using app prefix. So this prefix is necessary. Rhino is configured this way so that the functions that you define here and export need to be explicitly then imported kind of in the R code. We are not just dumping them into the global namespace of your JavaScript so that we can avoid name clashes and just polluting it. So everything that I define in the index.js file and mark as exported will be available with an app prefix. And you can also notice that I used this JS function. This one comes from the HTML widgets package. And this is just needed to mark this code as JavaScript to be executed and not just plain string. So let's try to run our application again. Before we actually do that, I forgot that we need to build our JavaScript. So the code that you write here is not directly included in your application. Instead, Rhino comes with a function for building it into a minified and transpiled version that is like understood by all browsers and is very fast to load. This gives you a couple of nice features. One of them is that you can use the directory structure here, and everything then will be bundled into one file, which is very quick to load. It also allows you to use the latest JavaScript features available without worrying for browser support. Because we run this code through so-called Babel, which does magic to ensure that any code which uses features which are not yet widely supported are converted into something that will be understood by everything. And what I need to do is to use Rhino build.js function. A couple of things happen here. First of all, we get the node dependencies required for all this bundling and transpiling. They are installed automatically. This only happens the first time you run this function. And then we can see some output telling us that a minified JavaScript file was created. And this file is placed in the static JS directory and included automatically. I don't actually need to do anything more here. We can now run the application. And as you can see, we now have years without comma separators. So this is what I wanted. So we can move on. Just before we do, though, I want to show you one more thing that Rhino offers and to help you maintain the quality of your code. And this is linter for your JavaScript. So Rhino actually comes with linters for all the languages that you might be using. So we have the lint_r function, we have lint JavaScript, and we also have lint Sass. Right now, I want to show you the lint JavaScript function. Again, using Node.js, it will scan my JavaScript sources to find any mistakes or style problems that I might have introduced. And in this case, it tells me that I have a missing semicolon in this file. And what I can actually do is I can run this same lint.js function with a fixed true argument, and this will try to fix the errors for me automatically. It does not work for all situations, but for many common errors and also in particular for styling, it is able to fix most of the things automatically. In this case, it just added this semicolon for me. So this is it for working with JavaScript in Rhino. We can now commit the changes. Just to quickly review, we modified our index.js function to define a function for formatting year labels, and then use that function in our Logic Rhinos module to actually change how labels are formatted. We also have a new file under the app static directory, which was generated for us automatically. We don't need to do anything more about it. All right. So the last thing, almost the last thing that I like to do with this application would be to change the layout here a little bit, because right now this is just a table and chart dumped together. I'd like to display them side by side and use some nice cards for that, so that it starts feeling like a kind of dashboard where we can see the Rhino's data set. And for this, I'm going to add some custom Sass styles, again, because this is just a good occasion to showcase how to do that in Rhino. So I'm going to start with modifying my main R file to add some CSS classes here, which I will then use to actually add styling. So I'm going to define two helper functions. Instead of wrapping everything by hand in divs and applying the classes, I'll just define grid, which will simply wrap all the arguments that we pass in a div and apply a grid class. And I will also have a card function, which will do a very similar thing, but apply the card class. Of course, we need to add div to our import. And now I will use this in my UI. So I will wrap everything in this grid function. I'm going to use CSS grid for actually putting the table and chart next to each other. And I'm going to wrap the UI of both modules in this card function. So this should do nothing yet. We just added divs with some classes. We now need to add styling for this grid and card class. And the way to write Sass in Rhino is to go to this app styles directory. We have the main SCSS file, and similar to the index.js file, this is where all your styling goes. Again, it is possible to use more files here and directories, and with use statement, you can import them and just like structure your styles in any way that you desire. This is really useful when your code base starts growing quite large. In this case, I will start by defining style for my grid class, and I just want to make it a grid container with 2 columns, just like this. So I'd like now to test how this affects the layout of my application. And to see the styles applied, I will need to, just like with the JavaScript, build our Sass first. So I will need to use the build Sass function. But here I'd like to showcase yet another useful feature that we have in Rhino. I'm actually going to start another terminal here, and I'm going to build Sass from here and use this wash true flag. What this will do, it will compile the main CSS file into a minified version, which is placed in the static directory and included by default. No need to do anything more. But it will keep running, and whenever I introduce changes to my main SCSS, I will be able to see them in application right away without needing to restart it. So let's try to run the application. You can see that we already have the table and the chart displayed side by side, which is what I wanted to achieve. Now I'd like to add some borders around the UIs of this of the table and the chart to kind of make it feel more like a dashboard. So going back to my main SCSS file, I'm going to just copy and paste a snippet here. This is a definition of a mixin, and this is one of the reasons why you might want to use Sass over CSS. So Sass is an extension to CSS. It's a superset of the language. You can just write plain CSS here if you want, but you can start using the Sass features as well. And one of the cool Sass features are mixins, which are kind of reusable pieces of styling that can be easily added to any class that you want. And here I'm going to use this mixin to add a shadow into our cards. So I just saved this file, and I won't be doing anything else but just refresh the application. And you can see that we have some nice borders added to our cards. They are now stacked together, though. I'd like to add some margin and padding around everything. So let's start with margin for the body of the document, and so also between the elements of our grid. After refreshing, we can see that it is now nicely separated. I'd still like to add padding inside of these containers to make it look a bit nicer. And now it looks reasonable to me. I will be commenting these changes. The last thing that I think I will add here is maybe a title at the top. And for this, I will just use a title panel from Vanilla Shiny. Find a population over time. And we're good to commit these changes. So to review what happened, we added some CSS classes to our main R file and also a title panel, then use those CSS classes to actually apply some styling using the main SCSS file. We compiled it into a minified version, which goes into the static CSS directory and is included automatically. And that's it. All right. So the last feature that I'd like to add into this application will be some filtering, which we will be then able to verify in tests that it works properly. And I want something very simple. I will just add another card here with a set of checkboxes from which you will be able to select which species you want to display. And I will only show the relevant information for those species. So once again, I'm going to start coding using my logic module. And in this logic module, what I'm going to do is to define, first of all, a helper constant. I'll just copy this over. Typically, we would like to determine this based on our data, but to simplify things a little bit here, I will just paste the 5 known Rhino species here. This will be used to define our checkboxes in the UI. And now I'd actually like to add a filtering function. It will also be marked as exported. Just like the table and chart functions, it will take data in the same format. And it will also take species. And this function has a simple task. It's going to only it will filter out the rows which do not match the species that we have here. And for this, I'm going to use dplyr filter function. So you can see that this is very simple. Again, it's just a toy example, but typically you would have something much more complex here. And again, now it makes a lot of sense to keep this separate from Shiny because this function is then much easier to test, as we will see in a moment. But first, let's actually add some filters which will use this function. So I'm going to go to my view directory and create a new file called filters.r. And just like before, it will be a simple Shiny module. So let's get the structure from our table. And inside of here, the UI will be basically a group of checkboxes. And we will have one checkbox for each Rhino species. And to start off, I want all the species to be selected. So let's add this argument. And this should be good for the definition of our UI. Now, the way I want to structure the code here is that this module will take unfiltered data and return a reactive with the filters applied as they were selected by the user. So here I will just use the Shiny reactive function, and this will become the return value of my module. And inside, just like we did many times before, we will use the function which we defined in logic Rhinos. This is the filter species. It gets data and the species selected by the user. And once again, you can see this separation of shiny and non-shiny in action. So we have this function, a very simple one, but you can imagine that something more complex typically would go there, which takes plain R data structures, a data frame and a vector of species. And it does some things with them, then we can verify that it does it correctly. And in the UI, we just plug this function in and connect it with reactivity with the rest of our interface. So once we have this module defined, we go to the main R file and once again import it. I want to use this style of importing, so I will just add filters to this init file as well. So now I can import it like this. And I'm just going to add the UI of filters in another card at the front. And lastly, we need to change a couple of things here in the server function. So the data that we fetch, let's rename it to raw data. And now we will pass this raw data into the server of our filters. And the output of this module will become the filter data that we then pass into the other two modules that we have here. All right, again, this was quite a bit of coding, so I hope there are not too many mistakes. Let's try to run it. It seems to work right away. We have a new card here with the species filter. As I unselect the species, you can see that we just see the data for the species that remain selected here. This is almost good. I will just change it so that we don't have these cards appearing like this, but instead side by side. To do that, I go back to my main SCSS file, just slightly change the definition here to 3 columns. The build SAS function keeps running at the background, so I just need to refresh the page to see the changes as I introduce them. And now I'm satisfied. I'm going to commit the changes. To review what happened, in the logic Rhinos, we added a function which actually handles the filtering logic. And then we defined a new filters module, which is responsible for displaying the UI for filtering and uses this logic defined here. We plugged in this module into our main R file. We also added an entry in the init R file so that we can use a short style of import. And lastly, we updated the styles so that the filters appear next to the chart and the table. All right, and this will be it for the functionality of the application. I have just the 2 last features that I'd like to show you in Rhino. And this is testing, this unit tests and end-to-end tests. So I'd like to start with unit tests. Rhino comes with a setup out of the box for writing unit tests using test.dat, and you can find those tests in this test.dat directory. Right now we have just this test main file, which actually is no longer valid because it tests the example code which we have removed. So I'm going to rename it to write some tests, and I would like to add a test for our logic Rhinos module, in particular for this filter species function. So Let's rename this file. And a quick note here, contrary to the rest of the code that is in app, in the test directory, unfortunately, as of now, we are not able to use a directory structure. It must be a flat list of files. We might be able to remove this limitation in the future, but for now, the recommended way to deal with this is to take, if we're writing, for example, a test for our logic Rhinos module, is to take the path of that module and replace the slashes with dashes. We also need this test prefix. It's a requirement of test.dat. So logic/Rhinos becomes test logic Rhinos. And inside this file, I'm going to define a simple test. I won't need test server, and here I will actually want to import my logic Rhinos module. And let's also fix the description here. I'm going to test if filter species works. All right. So to test this function, I'm going to define a mock data frame with some population information. But actually, this filter species function only cares about the species column, and it doesn't really care what's inside. So I'm going to have species A and B. And as I'm free to define any other columns, I will have an ID column here, which will be just like allowing me to easily verify that the filtering worked as expected. So now let's write a couple of expectations here. So I'm going to run the filter species on this sample data and tell it to just filter the A species. And my expectation is that this should leave the rows 1 and 3 here. So let's write this. And let's add a couple more expectations. If we filter by B, we should be left just with the second row. If we filter by non-existent species, we should get an empty vector. All right, this test should be good. To run it, we will use Rhino test R function. It automatically runs all the tests that we have in the test directory. Of course, we need to make sure that this file is correct. But to speed things up a little, all right, I forgot. Actually, the filter species return a full data frame, and what I need to do is to just take the ID column here. This is what I'm interested in. This is where how I'm verifying that the correct rows were filtered. So now going back to our test R, we can see that 3 tests were detected, all are passing, so we are good. And this is the last time I keep repeating that. I want to say once again, this separation of logic and view in this situation helped us to write a nice test for this filter species. So imagine now that instead of having this separation, just in this filters module, instead of this call to filter species, we just had a call to dplyr. And imagine that this is actually something more complex, like several calls to dplyr with like various arguments and such. If you want to test this code, this is actually very difficult. You would need to use that probably test server function and initialize this module and probably pass some mock reactive values inside of it. And this really gets quite complex. And by keeping this function separate and implemented pretty much with vanilla Shiny, we are able to write really nice and concise tests for this filtering logic. All right, let's commit the changes. Quick review. We removed the test which was no longer valid, and added one for our logic Rhinos module. All right. And the last thing that I would like to show you are end-to-end tests. So what are those? The end-to-end tests run your application in such a way that it can be automatically interacted with. For example, we can input some text or perform some clicks and then verify that the application behaves as expected. And to write end-to-end tests, we have this test Cypress directory. Cypress is the technology which we are using for writing those tests here. And we have this single app spec.js file, which is a very simple test, which actually just runs your application. And if it succeeds to start, the test will pass. And we can actually see this in action right away. So if we go back to our R terminal with Rhino test end-to-end function, we will be able to run all the tests. But I'd like to showcase another cool feature here, which is this interactive argument. Instead of running all the tests and just displaying a report at the end, this will open for us a window in which we can see all the test files that were detected, and we can manually run them and see the test running in action. So right now, our test just opens the application, and if it succeeds to start, then we are good. So the test passes. I'd like to write something more complex. Let's see this test once again. If we uncheck all the species here, we will see that the chart displays an error. And I don't really like that. Instead, I'd like to have some user-friendly message here. So what I'm going to do is first write a test which performs this action of unchecking and then verifies that a nice message is displayed here. And then I will try to fix my code so that the test actually passes. So we will implement the test here in this app spec.js. And as you can see, this is written in JavaScript. So you will need to know at least a bit of JavaScript to write tests using Cypress. I do want to say, though, that Cypress is one of the nicer testing frameworks that I have ever seen. It has like really convenient syntax and with minimal setup and boilerplate. So with pretty minimal knowledge of JavaScript, it's possible to look at the documentation of Cypress and start writing tests quite easily. In this case, I will actually speed things up a little bit and just replace this test with just nothing with a test which does something, and just give you an overview of what happens here. So we have two things here. This first part is checking all the checkboxes. So we use this get function and pass a CSS selector to find the group of checkboxes in our application. The idea that you see here, you can find it by opening developer tools in your application and then just looking at the HTML structure. And then using this each function, we tell Cypress to check all the checkboxes. The second part here is to take the chart, again by ID, and we want to take its parent and to see if it displays some user-friendly message. In this case, I would be expecting select some species. So we can try to run this again using our Rhino test end-to-end function. And the test should now fail because what happened, we unchecked all the checkboxes. We're waiting for 5 seconds now, hoping to see select some species message in this tab. It did not happen, so Cypress fails. The cool thing here is that we can review what was happening step by step. You can actually play around with this. You can expand some of this and kind of rewind to see what was happening. This is sometimes quite useful to understand why your test is failing. So I'm going now to modify my code so that these tests pass. And this is going to be a change in our logic Rhinos. No, not really logic Rhinos, but actually in the view and the chart. Here I'm going to, before I pass data into my chart function, I'm going to validate that it has more than 0 rows. For that, I will use Shiny validate function and say that we need number of rows in the data to be greater than 0. If that's not the case, let's display some message to the user, which is more user-friendly than an error. So let's try to first run the application to see if it does what I want it to do. Yes, if I manually uncheck everything, we see this message, which is a bit nicer than a red error. Now let's see if we can run this in Cypress for it to verify the same thing, but automatically. So again, I'm running it in this interactive mode so that we will be able to see what's happening. Let's run this test file. It opens up the application, unchecks all the checkboxes. It happens so fast that we don't actually see this, and then verifies that this filter species, this select some species message appears. The test passed, so we are good to go. Quickly, let's review what happened. We added an end-to-end test into our app spec.js file. We wrote it in such a way to verify something that was not working in the application. So the test was failing at the beginning, but then we modified our charter file to actually make this work, and it started working, so we're good. Here you can see a bit of noise. Cypress created for us a fixtures directory. We can actually commit this also. I won't be going into the details. This is where you can add some more code if you want to use more advanced features of Cypress. All right. And this is it for this leaf coding part. Actually, the very last thing that I'd like to show you here is the automation that comes with Rhino. So as we are committing everything to Git, and normally I would be pushing this to a remote repository, Rhino comes with a configuration for GitHub Actions, which will automatically run all the linters and tests for you and show you if they failed or if they succeeded. And you can see what this runs look like here. For a successful run, you can see what was happening. So we're linting R, JavaScript, Sass, running unit tests, end-to-end tests. You can see the detailed output of each of those comments if you want to. If something in the test fails, you can actually take a look at the logs here to see what was the problem. And this way, even if you forget to run the linters or tests by hand as you are developing, when you push to the repository, those tests will be run for you automatically anyway. And what we typically do in Absalon is we configure the project such that you cannot actually merge pull requests unless these automatic tests pass. And this way, there's no way around actually making sure that all these tools are being run and used to verify the quality of your code. All right, so this is it for my presentation. I know it was a bit lengthy, but it takes a lot of time to cover everything. And actually, there are still some features of Rhino which I did not mention, but I hope this kind of overview gives you a taste of what's available and what the workflow looks like in general.
All right, perfect, Kamal. Thank you so much for that, and well done on delivering the presentation. So we don't have a lot of questions from the chat. So I encourage anybody who's out there, if you have questions that are on your mind, please feel free to put it out. If anybody is, maybe a little uncomfortable with English and wants to put Spanish in the question, we can certainly translate that and ask Kamal. So feel free to do that. Kamal, to start, we have one very direct question that was asked a few minutes ago from Natalia. Do you have any recommendations to begin with using JS or JavaScript as an R user?
Recommendations. I think, first of all, it's typically best to kind of think what you want to achieve and try to learn it on the way when you actually need it. It's hard to just like start learning without a specific idea of how you want to use it. I do realize that sometimes you might be unaware, though, that you could use JavaScript in this case to help you a little. But I think some good things to start with is, for example, Shiny.js package. Probably most of you are already familiar with it. It allows you to call some functions defined in JavaScript from R, and you can use it for like simple customizations. It's also possible to use it in Rhino. Another thing that you might want to be doing, and this is actually, I think, something really worth recommending, you might want to take a look into our packages, also created in Epsilon, Shiny Fluent, and, well, basically Shiny Fluent. Let me quickly share my screen once again. So we have this package called Shiny Fluent, and this is something that allows you to use Fluent UI, which is a library for user interfaces coming from Microsoft, and it uses React internally. But this library allows you to use this in R quite often without writing any JavaScript code. I'd just like to quickly show you what it looks like. So I'm just able to launch an example dashboard right from my terminal. This is an application which is built in R Shiny using Shiny Fluent. And this is also a showcase of all the components that are available in this package. There are many simple components here, like just a checkbox, but there are more complex ones like a color picker. And I recommend maybe to try to use this library as well, because as I said, it is possible to use it with writing just plain R, but you will quickly find that for many of the more advanced features, you actually need to be writing some JavaScript code. And now with this package, it might be a bit challenging sometimes to do that, but I don't know, I think this kind of challenges might be actually a good way to have something to push you to learn JavaScript and have some particular use for it. And it's very worthwhile to take a look at the discussions that we have here in Shiny Fluent. There are some questions, many of them have answers which give examples of how JavaScript can be used to modify the functionality here. And also feel free to ask more questions here. So this is a little ad for Shiny Fluent. I don't think I have many other recommendations. In general, I would say be aware that JavaScript sometimes can be used quite efficiently add functionalities to your application, and then try to find a way to use it in that particular case. And my two recommendations would be Shiny.js, Shiny Fluent to have something to push you forward.
And I would also quickly add on that, Kamal, there's a great book I'll put in the chat written by John Cohen called JavaScript for R. There's also a YouTube channel, the JS for R. I believe that's the name of the group. But if you subscribe to Shiny Weekly, you'll be able to see all of those videos as they come through. But that's also a really amazing resource. So next question from me, Kamal, because I've been using Shiny for a long time, and maybe you can expand on why this is bad practice, but it's actually quite common for people to put a lot of logic in the global.r file or outside of the Shiny or UI server. As you were kind of talking through this app, anybody who's watching may have noticed that we don't really do that in Rhino. Can you expand a little bit upon why we don't do that? And for those who want to use that sort of approach, what would you give them as advice?
Absolutely. So I think this question actually covers a couple of related problems and things that you might want to achieve with your application. And let's maybe start with the first thing that you typically see in applications, which is a list of library calls, which introduce all the packages, and then you are just using them in the application. So I tried to address this a bit as I was working with the code. The idea behind Rhino is to make things more explicit, more organized. The problem with having one file with a list of all the libraries is that sometimes you will see two different packages introducing a function with the same name. And then we have a name clash. One of the packages overrides the name from the other one. If you're lucky, you'll get a warning and notice it and hopefully somehow address the issue. But sometimes it will be a source of really difficult to find bugs. And also, in general, we just don't want to have our namespace cluttered with hundreds of different names from the various packages introduced. So this is the first thing, the first reason why we don't have a global file which does all the importing. And instead, each file separately at the top has this box imports, which explicitly say what packages and functions are used in that given file. Now, a kind of related topic is global variables, constants and mutable state. So this is, again, something that we can break down a little bit. First of all, it's a typical thing that you need some kind of data to be reused across your whole application. And now this data can be of various types. First of all, we might have unmutable or constant data, things that don't change from beginning to end. Maybe they are loaded at the beginning of the application running, but then they remain constant. And this is actually very natural and easy to achieve in Rhino. What you will do, you'll just have you can have a file like in the logic, you can define a file, for example, called constants, and just put your constants there. And whenever you need to use one of those constants, you'll use a box use statement to import the constants file and use the constant that you need. And this is kind of similar to having this defined in the global R file, but the difference is, again, that we are explicit for each file that it actually uses those constants. Now, if we want to have a global variable which actually changes over time, things get a little bit more difficult because directly with a box, you won't be able to modify as you would be able in a normal scenario. So imagine that in a constants module, we define a variable, then we import it in another module and try to modify it. This won't work. And there are ways to go around this. And actually, I think I won't be going into the details now because this would take a bit too much time. But we will have an article on that in our documentation soon. There are a couple of ways to approach this. One way is to define a special environment, which is used by the other, which then can be imported by the other modules. And then inside that environment, it's kind of like a mutable container for whatever global mutable state we might need to use. It's a slightly different case if we need variables per user session, then the proper place for that is session user data. And yeah, this is a topic which, depending on the particular needs that you have, there are good solutions to be used in each of those situations. But the overarching reason for having it different than in vanilla Shiny is, first of all, trying to be explicit about what we are using. This makes the code more maintainable and lets us allow some typical errors. And then I think it's also worth to mention a second big reason, which is actually completely independent of R and Shiny and everything. And this is just that whenever you want to use some global variable, think twice or 3 times if you actually need a global variable, if there is no better solution for that, because global state makes your code difficult to test. It makes it easier to break. A piece of code in some completely unrelated place can change that variable, and this can break something that uses that variable in a completely different place. And there are additional reasons why we don't want to use global variables. For example, it makes the code difficult to test, because if you have a function which uses such a variable, now before that test, you need to somehow modify it. So it just gets messy. So global states and variables are best avoided. That's why Rhino doesn't have a default way of defining it in a global R file like you would have normally. Instead, there are specific solutions to particular needs that you might have in the project. Once again, this will be at some point nicely described in our documentation. But yeah, hope that answered the question.
Yeah, it definitely did, Kamal, and thank you for that. I just wanted to make a personal comment that in my own personal journey of learning JavaScript, I can't even tell you how many times I forgot to put a semicolon and like don't understand why it broke and go back and find it. You showcased in the talk that using the lint.js can be super helpful for something like that. For those who aren't very familiar with linters, can you expand a little bit upon why people use linters and why that's really important when you're developing, for instance, in a team?
Yeah, absolutely. So a linter is basically a tool which is able to automatically parse the code of the given language and detect some errors or mistakes or styling issues in that code. And the types of errors and styling issues that it can detect can be really varied, actually. From very simple things like a missing semicolon, sometimes to detecting complex problems like you are using this variable in a wrong way and things like that. And the reason for using a linter is that it will be able to, like, especially in the more complex cases, to flag potential issues. So, for example, okay, this maybe does not apply to R exactly, but because its linter is not that advanced, but in other languages, you will see errors like you are using an uninitialized variable here, and this will probably lead to bugs in your code. So linter can directly tell you which pieces of code are suspicious, which pieces of code can have bugs. But then even without it, what linter also does for us, it enforces a consistent style for your code. And this is important for a couple of reasons. The first one is that it just ends the discussions and wondering how to style your code. So if you have a tool which automatically formats your code, you won't be like wondering with your colleagues and spending time discussing how it should look like, because we have a tool which automatically does that for you. But also it actually makes it more easy to read for other people. If all the code uses consistent formatting, including things like indentation, the style of the brackets, the way the arguments to functions are formatted, this really makes the code much easier to read, and it starts to matter a lot in big code bases. because you keep returning the code again and again. You read code typically much more than you write it. So it's very important that it looks consistent and readable. So I would say these are the main reasons. Basically, it helps you to detect some errors and also to make sure that your code is readable. And this matters a lot, as you can imagine, if multiple people are writing, because then everybody has a slightly different idea about how the code should be styled. And linters make this defined.
Okay, perfect. Thank you so much, Kamal, and that's a really great answer. This next question kind of comes at maybe one or 2 points. You had mentioned that it's quite important to remember to use the box ... reload function. And when I first used box, I didn't realize this concept, and I was changing my code and I was going back and going, why aren't things updating? So maybe if this question is just to help people remind themselves that they need to do that, can you explain a little bit about like why we have to do that and how box kind of works under the hood?
Absolutely. So what you could see from the application that I was developing, a single module like that logic Rhinos one was used across our application. It was imported multiple times. So we had multiple box use statements which actually imported that module. But behind the scenes, box actually loads this code only once. It does not try to parse and load the code every time you load it, because that would be inefficient. And if we took that like to the extreme and like tried to then for each module load everything that it loads once again, we could spend really a lot of time just parsing the same R code again and again, and also defining the same objects again and again, meaning huge memory usage, and introducing many other issues. So basically, the box caches the module, which makes them work as you would expect. Each piece of code is only appears in your application once, and box use is kind of a way to refer to that piece of code and to access the exported functions from that piece of code. So what happens is box, whenever it sees a box statement for a module which is not yet loaded, it loads it and puts it into the cache. And when it sees a box use statement for that module again, just retrieves it from the cache. And this reload function, what it does is basically removes the module from the cache, so that the next time you try to box use it, it will be loaded from the disk again. And this is necessary if you are modifying the file and want to see the changes. If you're just like in development mode, this is what you will just need to do. In your application, you will never need to reload the modules, like when it's live, deployed, and running. You do want module caching. This makes your application run fast. Only in development, it might be sometimes useful to use the reload function to see the changes right away. Of course, another way is to just restart the R session, but using the reload function is quite a bit faster.
Okay, fantastic. Thank you for expanding upon that, Kamal. Now, my next question, since we're talking about the box package, is that you showcased in the talk that the best practice that you should employ is to go box use, name of the package, open bracket, then all the functions you want to use. But we can also do the package, open brackets, ... Now, when I was first starting to use Rhino, I found it to be a little inconvenient. I kept forgetting about certain packages, so I wanted to just use ... for all my packages, and I had the thought, oh, I'll go back later and I'll fix it all. Can you give some advice or general guidelines on why that is bad practice and you really should be looking at this specific dependency management as an important feature?
Absolutely. So the box use 3 dots basically bring us to similar situation as we have with library and with the library function. And the reason why we don't want to use that is that many packages will have tens or hundreds of functions inside. And if we just import everything, it will lead to name clashes. That's why we want to be explicit about what we are importing. And this is the primary reason not to use the 3 dots. Now, as you said, it might get a bit inconvenient sometimes to keep updating that manually. The way I approach this is that if I need only a couple of functions from a package, I will typically include them, just import only those couple of functions. And if I keep using many functions from the same package, I will import the same package and not the whole package and not worry about the specific names. You could see I was doing that with dplyr, for example, and actually Shiny also. So when I'm calling those functions, it does add some additional text. So I need to refer to like dplyr $filter, not just filter. But I find that this is actually quite readable, and then I don't need to keep updating those box use statements all the time. Having said that, we might actually in the future be able to generate the box use statements at the top automatically and then detect potential name clashes and just warn a user about it. This is something that might appear in Rhino in the future. But in the end, we still want to be explicit because that's the best way to avoid errors arising from name clashes and things like that.
Okay, once again, great answer, Kamal, and thanks for expanding on that. So in the talk, you also talked about how if we want to use JavaScript, we can, of course, go to app/js/index.js, and we can write pure JavaScript there. I feel like most people who are getting used to Shiny probably take their first steps into the JavaScript world using the Shiny.js package. I remember when I specifically first figured out how to do Shiny.js hide and reveal, it was like an eye-opener to me how quick and efficient that was. Are there any known limitations to using that package when you're developing an app that's based on Rhino? Or is there any specific way you need to approach that?
So I wouldn't say that there are any limitations, but there might be some quirks or things that you need to be aware of when trying to use Shiny.js in Rhino. One of the things that might be not typical is that you need to marker functions exported, and then in R, they are available with this app.prefix. And this is something that you need to take into account when trying to call JavaScript functions from R using the Shiny.js package. The details, you can actually go to GitHub discussions, and one of the discussions actually explicitly asks these questions, and there is a nice, we show an example of code which shows you how to make sure that this prefix things is handled correctly. Another thing that you need to be aware of is like something not really related strictly to Shiny, but to Rhino, but more general to Shiny, that we structure the whole application using modules. So all the inputs and outputs are scoped. They have prefixes consisting of the IDs of the modules that contain the inputs and outputs. And if you want to hide something or show something from a different module, you need to be aware of that prefix. You will probably need to somehow pass the ID between the modules if you want to avoid hard coding them. So this is another thing that you need to be aware of. With all that said, like as I said, you should be able to use Shiny.js as long as you take into consideration all those things. But I need to say that a couple of things are not as convenient as they could. For example, this calling JavaScript from R requires you to type the same things in a couple of places. Like you define the function in JavaScript, and then you need to add the name of the function somewhere, and then you can call it. We are actually thinking about making this a bit simpler. Like Rhino could come with some nice mechanism where all you would need to do is to define a function in JavaScript and then just call it from R. And again, this is something that we might introduce in the future. For now, Shiny.js is fine. With precautions, you should be able to use it to full extent.
Okay, wonderful, Kamal. Only a few more questions. Thank you, everybody, for sticking around as long as you have. I believe at the beginning of the talk, you mentioned that two of the main dependencies that we have when using Rhino are to have Node.js installed as well as Yarn. And this is very important for these linters to work. When this first came out, particularly when I was speaking to people in the pharma industry, whether it was because it was primarily because of lack of permissions on their computer, they couldn't install Node or Yarn. Can you, for people who have that same sort of problem or encountering that, can you describe some of the things they have to do differently, what things, if any, they won't be able to do, and just expand on that a little bit?
Absolutely. So first of all, Rhino in general will work without Node.js and Yarn installed on your system, but there will be a couple of limitations. And in particular, the tools for JavaScript and Sass won't work, and the end-to-end tests also won't be available. And now, for Sass, you can actually use the R package. It is possible to configure Rhino such that it will build Sass not with Node.js, but with the R package. This is done using Rhino YAML, the configuration file. You can read about this in our documentation. You won't have the linter for Sass, though Node.js is a requirement here. For JavaScript, you are actually able to just use a plain JavaScript file and include it without any bundling, transpiling, or anything, just like you would do in a typical Shiny application. And for that, you'll just need to create that file in app static directory and include it manually in your application. It should work for you just fine. For end-to-end tests, you will need Node.js to run them. So this is a function which strictly requires Node.js. Other than that, all the other features do not depend on Node.js, so you should be able to use them freely. The workarounds or like changes that I mentioned, you can read about them in our documentation. Also, there are a couple of related discussions in our GitHub. Yes. The last thing to say here is that making sure that Rhino works on all platforms and doesn't really require any additional privileges and dependencies is for us #1 priority now. We will see how far we can get with this. Like Node.js brings some pretty cool features which we don't want to remove, and implementing them completely independent of Node.js, or maybe installing it transparently, might be quite a challenge. So we will see how far we get with this, but we will be definitely striving to make sure that Rhino provides pretty much the same functionality, even if you don't have all the system dependencies or the privileges that you now need. So yeah.
Okay, great answer. Kind of expanding on that a little bit, maybe this is somewhat of a loaded question because you guys are doing a lot of work. What do you envision for the future of Rhino, and what are going to be some of the features that users can expect, say in the next 6 months?
So we do have a big engagement in Rhino planned for Q4 this year. So you can expect a new release of Rhino by the end of this year with some additional features. And here the priorities are, first of all, as I already mentioned, ensuring that Rhino works on all systems without additional privileges and without additional system requirements. To the biggest extent that this will be achievable, we will see exactly. We also are thinking about adding support for things like Shiny Test 2, so things that typically you will want to use with Shiny applications, and they should work with Rhino out of the box as well. We will be also looking into integrating Rhino with the other packages that we have. So we have, for example, Shiny Router, which allows you to basically add routing to your application so that the URL can determine which view of the application you are seeing. And right now it does work with Rhino, but it does not work perfectly. There are some issues which have their workarounds. One of our goals will be to make sure that Rhino works really well with all the other open source packages that we have in Absalom, creating some kind of Rhinoverse, you could say, so that really the set of packages can be used to build applications the Absalom way. What's going to come after that, we will see. We do have some pretty cool and big ideas in mind, but it's really hard to say which one we will dive into. We are looking at such wild ideas as, for example, introducing ORM to Rhino. So if you're familiar with Django, a Python framework for building web applications, they have something like models. Basically, you don't just fetch tables from the database. You have some nice way to refer to rows in your database, to work with them, to save them and such. And this is something that we thought could be added to Rhino as well. But this is already a very big idea. And there are many others that we have. Some are much more simple. For example, coverage reports. We have unit tests, but you cannot generate a coverage report. This is due to some limitations of the cover package, the only existing package, as far as I know, for generating such reports in R. We might be able to overcome those limitations. So this is another thing that might appear in Rhino in the future. But we will see. We will be trying to address user needs, and we will have to kind of do some research to understand which features are most important to our users. So we will definitely prioritize those.
All right, thank you so much, Kamal. Well, that's it for all the questions that I had. Thank you once again to the LatinR conference for having us here today. And I know this was a pleasure for both of us to be a part of this. Thank you for everybody who was able to join today. Kamal, is there any last words you'd like to say on this?
Not really, just general thank you. It was a pleasure to present here. Always happy to answer questions in our discussions, or I'm very happy to see any issues or bugs reported for Rhino. And other than that, I hope this got you at least a bit interested in our framework. And yeah, I hope that your next application will use Rhino.
Well, thank you both for your time. We really have a lot to learn. So hopefully next year we can share with you our many projects made with Rhino. Hopefully. Well, thank you again for sharing this time with us, and see you next year in the next edition of LatinR 2023. So thank you again, and see you.
Thank you, Macarena.
Bye-bye.
Bye-bye.